The bright yellow fruit sitting on your kitchen counter is facing a disease that could eliminate it from global markets within a single generation. It is the cheapest item in the grocery store, but the modern banana is a biological dead end. 10,000 years ago in the forests of Papua New Guinea, the original wild banana was unrecognizable. It was small, stubby, and packed with rock-hard black seeds the size of peppercorns. The flesh was so thin and bitter that eating one felt more like chewing gravel than eating fruit. But early farmers saw potential. Through generations of selective cultivation, they cross-pollinated mutant seedless varieties, prioritizing the plants that produced soft edible flesh. They eventually created a sweet seedless fruit, an early act of agricultural engineering that predates the cultivation of rice. This convenience came with a permanent biological consequence. A banana without seeds cannot reproduce on its own. To grow a new plant, a farmer must take a cutting of the root system and replant it in new soil. Every single commercial banana grown from that point forward was a genetic clone of a parent plant. Every plantation, regardless of its size, became a landscape of identical copies. The exact trait that made the banana a consistent, predictable consumer product also stripped it of the genetic diversity required to survive an evolving pathogen. In the 1870s, entrepreneur Minor C. Keith discovered that the volcanic soil and tropical climate of Central America allowed banana plants to grow faster and produce larger bunches than anywhere else on Earth. He merged his operations into the United Fruit Company, focusing the entire empire on a single variety, the Gros Michel. Within 2 decades, the company owned over 1 million acres of land. They controlled the railroads, the telegraph lines, and the ports across 6 different nations. In many cases, the executives in Boston held more actual power than the elected officials in Central American capitals. This dominance gave rise to the Banana Republic, nations whose political systems were little more than rubber stamps for corporate interests. When workers pushed back, the company turned to violence. In 1928, the Colombian army, pressured by United Fruit, used machine guns to break a strike in the town of Cienega, killing hundreds of workers and their families in a single bloody afternoon. Geopolitics followed the company's bottom line. In 1954, the CIA orchestrated a military coup in Guatemala to overthrow President Jacobo Arbenz. His crime was a land reform program that threatened to redistribute unused company land to poor farmers. The resulting civil war lasted 36 years. While the boardroom in Boston accumulated immense wealth, the workers lived in company towns, bought food at inflated company stores, and were paid in worthless company tokens. The cheap prices found at grocery stores in the United States were bought with military coups, labor massacres, and the systematic exploitation of an entire hemisphere. But the United Fruit Company had a vulnerability that no amount of political influence could fix. They were fighting a war against a fungus that did not care about their monopolies. In the early 1900s, Panama disease appeared. This soil fungus infiltrates the roots and chokes the plant's vascular system, preventing the flow of water until the leaves yellow and the entire plant collapses from the inside out. Because every Gros Michel was a clone, they all shared the exact same DNA. Not a single plant out of millions had the genetic variation required to fight back. In a landscape of identical organisms, a single pathogen can move through an entire region without meeting a single biological barrier. By the 1950s, the Gros Michel was functionally extinct as a commercial crop. The fruit that had built an empire and dominated the global market was gone. Desperate to save their infrastructure, the industry pivoted to the Cavendish. It was blander and bruised more easily than the Gros Michel, but it possessed one necessary advantage. It was naturally resistant to the fungus that had annihilated the previous crop. The Cavendish saved the industry's bottom line, but the companies merely swapped one clone for another. They didn't solve the problem, they just reset the clock. Despite witnessing the total collapse of the Gros Michel, the banana industry immediately planted the Cavendish as another global monoculture. They chose the short-term efficiency of identical plants over the long-term safety of genetic diversity. The consequences arrived in 1990. A new, mutated strain of the fungus, Tropical Race 4, was identified in Taiwan. Unlike the original disease, this strain bypasses the Cavendish's defenses. TR4 spread through Asia and jumped to Africa before arriving in Colombia in 2019. Its detection triggered national emergencies and immediate quarantines across the region, but the fungus moves through the soil and water with terrifying ease. Containment is nearly impossible. TR4 persists in the ground for 30 years and can be carried between farms on a single worker's boot. There is no chemical cure and no soil treatment that stops it. Today, researchers are in a high-stakes race to develop a genetically modified banana that can resist TR4. They are splicing genes from wild, seedy relatives into the Cavendish, hoping to find a solution before the commercial crop disappears. The collapse of the Cavendish carries weight far beyond the grocery aisles of the West. In nations like Uganda and Rwanda, the banana is the primary dietary staple, providing millions of people with their daily calories. For these families, the spread of this fungus is a direct threat to food security. This cycle only ends if the global market moves past the demand for impossible uniformity and accepts the cost of genetic diversity. Otherwise, we will simply plant the next identical clone and wait for the next fungus to find it.